Hey, welcome to Solving Science. Wow. Let's let this running. In 1801, 224 years ago, a young chap called Thomas Young fired light through two slits in a board. And what he saw was an interference pattern of dark and light and dark and light and dark and light lines. And that has triggered 224 years of absolute mystery that nobody can explain. How can light interfere with itself to create a waveform pattern? Okay. Now, the mystery deepened about 100 years later when Taylor, using much more sophisticated equipment, managed to submit a single electron at a time. Now, here's a big deal. You've got one particle, one electron, being fired at two slits. And the answer, if you repeat that again and again and again, firing one particle at a time, you still see the waveform pattern. Now, it triggered Niels Bohr and Werner Heisenberg to set up wave-particle duality and the Copenhagen principle, saying that depending how you look at things, particles are waves and waves are particles, and they are all one part the same thing. And the conclusion of the Copenhagen principle was we as human beings would never get to a deeper level of understanding of wave-particle duality. Okay. So I've been researching this through the eyes of expanse tension theory. And this is kind of a big thing because so far expanse tension theory has applied to the big stuff. It's applied to galaxy rotations and star formation cutoff and expansion of cosmic universe and black holes, if you've seen the recent application to black holes in the event horizon, and star formation and lots of things like the Hubble tension. It's been galactic cosmic scale application. So the real first time that I've thought, let's try and apply expanse tension theory to something really small, like firing an electron or a neutron or something else at two slits. So it's quite a big deal. Can expanse tension theory give us an answer at the very smallest of scales, or almost the very smallest of scales? And the answer is yes, it can. Now, my research says this, and I love this. So experimental scientists, experimental physicists, throughout this 224-year period have concluded some very, very clear experimental physicist things. They say the wave supports, guides, and propagates and supports a separate particle. Okay. That's consistent in almost every single research paper coming out of this, that the people conducting the experiment are saying the wave is separate to the particle. And they've been crying out for a field to propagate a wave. And no, that's not space-time, which is geometry. That's just a transcript on paper. We need an actual field. We need a medium. We need a luminiferous ether. Robert Hooke. Let's talk about Robert Hooke, the man who knew too much. 1665 gave a lecture on the wave theory of light. And he actually said he believed light was propagated through a medium. Yeah. Now, those ideas were wiped out by Newton and then later wave-particle duality, who removed that. But the people conducting the experiment for 224 years, they believe there is a separate wave front, waveform, a medium that's then supporting and propagating. So how does expanse tension theory solve this? Well, firstly, we have the Holland-Higgs quantum field, fully permitted within quantum field theory. I've invented nothing. Quantum Field Theory Handbook 101 says I can have a gauge-invariant singlet scalar field that can couple and uncouple to the Higgs field, or any other field that I want. So Quantum Field Theory Handbook 101 says I can do that. So we've now got an all-pervading, incredibly low energy field, but that can propagate waves. That's clever. Expanse tension ripples, ETRs. they're like gravitational waves, except gravitational waves in space-time can't propagate anything because they're geometry. They're a geometric manifold that can't support, hold, store energy. Okay. So expanse tension ripples are real waves in a real field that can propagate real interference patterns. So how do we explain Thomas Young's experiment? Well, think of those video footage of the jet nose cone of a supersonic jet, and you get a wave front, a pressure wave in front of the nose of the jet that creates the sonic boom, the sonic boom, the cone that precedes because a wave is being deformed. Imagine shooting a bullet through water. The wave deforms ahead of the bullet, okay, creates a wave front, a pressure shock wave front. That's what's happening in the Holland-Higgs quantum field of expanse tension theory. A particle is fired, an electron. The wave front, the expanse tension ripples in the Holland-Higgs field propagate a wave front of tension gradient in a tension field ahead of the particle. When that wave front hits both slits, it passes into both slits, leaving a lower tension region which the particle can follow into. Now, the two slits are incredibly close together, and the drawings and illustrations show a wider obstacle in the middle, but there isn't. The slits are incredibly close together in real life. But as the wave front propagates through the two slits, it carries the particle through and guides the particle through. Now, beyond the two slits, two new wave fronts are formed, which instantly start interfering with each other. Now, the interference pattern of those two wave fronts creates the crest of high and low peaks, high and low tension gradients, which create definitive channels of the interference pattern, which then can set the particle onto a specific path that aligns up with the statistical interference pattern. Okay, the particle emerges from one of the slits. The particle only ever passes one slit. It doesn't split into two. There's no quantum weirdness. It's not some position of being in everywhere at the same place. It's not sitting on the back of a cat in a box. The particle passes through a single slit. And I'm an engineer, and I like that solution because it's much more logical and parsimonious and common sense. The particle passes a single slit. When it emerges, it enters one of these low tension channels of the expanse tension ripple interference pattern, which guide it smoothly all the way to the detecting screen in the distance. You repeat the experiment as the animation will show. Now, I'm going to post a part B to this video. This is Solving Science 14 Part A. The video, which I've just showed, is Part B. It will be posted alongside this video. You can go and watch, and I try and simulate with an animation how the particle can actually be guided into what looks like an interference pattern, a statistical pattern. Okay. Wave-particle duality could end with this interpretation. The Copenhagen interpretation, which Einstein hated, and lots of others hated the Copenhagen interpretation because it ends physics. It just says humans can't know anything below this point. Here be dragons. Could be over. Could be new realm of a new era of physics. So for the experimental physicists, I give you an early Christmas present. It's still only November. I give you a medium in which to propagate a particle. You're welcome. So please take a look, watch the video. I'll link to the document in Zenodo. It's an easy 116-page read of scientific justification theory, proof, mathematics, etc., which has been created then for people to scrutinize, to say, does this solve this problem? Okay, now remember, I'm not putting something forward that just solves Thomas double-slit experiment. The series solves dark matter, dark energy, the Hubble tension, and lots of other things. So the same framework, the same principle, the same maths, the same idea of a density-dependent coupling, a modulation where density and mass density fall below a certain threshold, change physics, and allow all the different anomalous accelerations and inflections that we see. And now, I hope, it can explain an interference pattern of a particle that doesn't interfere with itself, a particle that is guided on the crest of a wave through to form an interference pattern. Exciting times. Anyway, please share with a scientist. I'd love it. And please subscribe. Bye-bye.